Hello, if you're watching this video, this is the reteach for balancing charges or for writing formulas. And this was something that your work showed that is something that you need a little bit of work on. So here we go. The first thing to remember is that ionic compounds want to be neutral. If they aren't neutral, they're not an ionic compound. So the total charge of all the ions must be zero. The other important thing to remember is that you're only ever going to have two types of ions. You don't get to make up a third type of ion to make things balanced. You will only ever have two, at least in this class. So let's ignore real ions for a moment and just talk about X and Y here. Here we have an X1 plus and a Y2 minus. And as you can see, the total charge here is not zero. If I have a positive 1 and a negative 2, that does not equal 0. So my process is, well, which one do I need more of? I have less positive than negative, so I'm going to add another positive. All right, now that I've added another positive, let's double check again. Positive 1 plus 1 minus 2 now equals 0. So now this is neutral. All right, let's do it again with a slightly harder example. Here we have x3 plus and y2 minus. So clearly here, we do not have a neutral charge yet. I have less negatives than positives, so I will add another negative. But I still don't have a total charge of 0, because now I have too many negatives, so I add another positive. Yet still, the total charge is not 0. I don't have enough negatives. I just keep going back and forth. Whichever one I don't have enough of, I add another. And you'll see that I never added a y minus 1. I'm not allowed to. Y is minus 2. I can only add the things that I am playing with right now. And in this example, that's x plus 3 and y minus 2. So here I have not enough negatives. I'll add one more negative. But now I'm neutral. Now the total charge is 0. 3 plus 3 is 6. Minus 2, minus 2, minus 2, negative 6, brings us back to 0. So that's how you would balance the charges. And if, the polyatomic thing is confusing you, then just don't write it. Leave it as an X or a Y. And worry about it at the end when you're writing the formula. When you're writing the formula, you're going to take your work for balancing the charges, and you're going to use that as a guide. The formula always follows the same pattern. You give what the first ion is, how many, the second ion, how many. For example, here on the left, we know we got X and Y as our two ions. So now we just got to count, well, how many X's do we have? How many Y's do we have? And I add those numbers. And that's really it. It's a lot easier than a lot of us think it is. Now here on the right, again, I'm playing with X and Y. But how many X's? How many Y's? I don't care about the charge. I care about how many. I see 2 X's and 3 Y's. All right, so now I have balanced the charges, and then I've turned it into a chemical formula. Well, what would this look like in a real situation? Well, let's do that again. I just went from X and Y to actual ions, just to show you that it literally doesn't matter. It changes nothing. If our X is actually K, 1 plus, then instead of the X, I'm going to put a K. If my Y is parentheses, CO3 parentheses, then I'm going to put that with the parentheses instead of the Y. So on the left, my X is K, my Y is CO3. Now, scientists are lazy, so that 1, we don't really need it. And since we're not going to have a number there, we don't really need the parentheses either. That said, I kind of prefer to write it like this, although this is technically correct. All right, let's look on the right. Okay, my X is aluminum. My Y is, again, CO3. So instead of X, I'm going to put Al. Instead of Y, I'm going to put CO3. But look, it's the same thing. I just replaced my X and Y with the actual ions. No charges, just what the symbol is, and little numbers on the bottom for how many. All right, so now we got some examples. First, you're going to balance these charges. And then please write me a formula for it. All right. This one's already balanced. What about this one? Okay. This one. Notice again, I'm not writing down the charge, just how many. This one. And now we're just going to do it. And it's exactly the same as what we were doing before with X and Y. We're just at the very end going to replace X with NH4 in parentheses and Y with CO3 in parentheses. But first I got to balance the charges. How many of the NH4? How many of the CO3? And that gives me this. All right. Balance the charges. Use X and Y. Balance the charges. Write the formula with X and Y. And then instead of X, put Ca. And instead of Y, put parenthesis, PO4, parenthesis. And we get this. All right, now we're going to look for these symbols. Just as a review to see if we can do everything that I would like you to be able to do this unit. If I give you calcium chloride, I want to know what the chemical formula for that is. But we're going to do it in steps. Step 1, please find me the symbol for calcium and the symbol for chloride. Here we go. I don't know how many I have yet, but I know it's Ca, I know it's Cl. Next, I gotta look up the charges. And there we go. Now that I know the charges, I have to balance the charges. And there we go. And now that we've balanced the charges, we need to write the formula. Remember, the formula is just going to be Ca, little number for how many, Cl, little number for how many. And there we go. And that is the big problem that I'd like you to be able to do, to take a name and bring it all the way to a chemical formula. All right, congratulations, you survived.